Hello everyone, we are doing an experiment to determine the strength of a magnet at various distances. To do that, you need the following apparatus. For this experiment, you need a number of magnets, a ruler, pen and paper to record your results, a digital scale to record the changes in masses, which will be subsequently changed to forces, a retort stand with a clamp on it. To set up the apparatus, you need to place one bar magnet on top of the scale pen and press the entire button to reduce the reading to 0 as shown there. By adjusting the distance between the magnets to about 2 centimeters, we actually see that the reading on the scale is actually 101.5 grams, and that's the number that you're going to record for the 2 centimeter distance. The table of results which I've populated, it looks like this. As you can see, on the first column is the distance, and on the second column is the mass that was recorded, and we need to convert that mass into kgs by dividing by 1,000 and then multiplying that mass by 9.8 to give you newtons. That's the reason why there's that force column which you need. And then thereafter you need to do a plot of the distance of force versus distance, and you can make inferences from there. If you want to make it a linear curve, you can actually make a curve of F versus 1 over R. And remember, your R should be in meters, not centimeters, because every unit here should be standard unit. From these results, graphs can be made and inferences can be deduced, and you can actually make some other modifications or extensions, and some of which I'm going to illustrate here, such as increasing maybe the number of magnets at the same position and checking what happens there. I'm going to show you one just now where I'm going to put maybe just one magnet at this distance of 10 centimeters between the magnets, and let's see whether there will be any impact on the reading on the scale. As you can see here, the reading is actually 1.6 grams for the distance of 10 centimeters when you have got only one bar magnet. We can increase the size number of bar magnets, and let's see what happens if the distance is kept constant there. Okay, let's have a look with one bar magnet, then we add them successively to about 5. Let's see what happens in terms of the readings, and that is one variation you can do with your experiment. With 2 bar magnets being supported by a retort stand, you can see the reading now is 2.8 instead of 1.6 when you had only one magnet there. As you can see, just by looking at what you have done here, just increasing the size of the magnet when the distance is kept constant, you can see that the force that is actually recorded here is actually reading in mass. It is actually 2.8 grams. Let's see what will happen if you actually put a third magnet on top, whether the reading will change. Okay, with 3 magnets on the same height between the magnets, you can see what you have got now is a reading of 3.8 grams there. The process was repeated. As you can see, as you increase the number of bar magnets at the same distance between them, we found that the mass which is recorded by the scale also increased from 1.6 to 6 grams, and that's the effect of increasing this number of magnets whilst you keep the distance between them constant. So magnetism can also be increased by increasing the size of the magnet. The readings from these 2 experiments, you should take note that they won't be the same as the ones that you will do, because this depends on the type of magnets that you are using. So these results are not to be taken by you, but just for illustrative purposes only. Thank you.